Pythagorean's theorem, SOHCAHTOA, only work when you have right triangles. Is every triangle a right triangle?
No.
No. Okay? So, you have to have ways to determine missing parts of triangles even when you don't have right triangles. Okay? And one of those ways is by using what we call the law of sines. Okay, and I'll give you the rule here for a second, but what I'm about to show you is something you'll have to do for your quiz on, which would fall under category 5.1. Explain what trigonometry is, how the formulas are derived, which is what we're doing here, and its uses. Okay, so we're going to derive the law of sines. I'm going to show you, or prove basically, how the law of sines works. Okay, and the way we prove it is really a way you could figure out missing sides the long way if you forget your law of sines. So you're going to be given a picture like this, and I'm going to just say derive the law of sines. That's going to be your instructions on your quiz. I'm going to give you this picture. We're assuming that these angles are not right angles. Okay, C maybe looks like it's close. I mean for it not to be a right angle. Okay, so we don't have any right angles up there right now. Alright, so we're going to derive the law of sines. The first thing you would do, okay, if you didn't know any of the angles, okay, or you didn't have a right triangle, is actually create a couple right triangles. How might you create a couple right triangles? Okay, split, and it wouldn't necessarily be splitting in half. It might split it in half, but we don't know for sure it's splitting in half because we don't know if this is an isosceles triangle. But either way, just drop an altitude down here perpendicular to the base. Okay? So we're going to drop an altitude down there perpendicular to the base, and we'll just call that the height of the triangle. Logical, right? If side C is our base, then here H would represent our height. Okay? Now, because we don't know the angles, we don't know if we have an isosceles triangle or anything like that, it might look like I split it equally into half, but we don't know for sure. Okay? Same thing with the angle up there. We're just dropping that, that altitude or that height straight down. Okay? Okay. Now, we do have some right triangles. So when you do have right triangles, you can use SOHCAHTOA. Alright? This is called the law of sines. So could somebody give me a sine ratio that would now be true using the letters that are in that picture? The sine of something equals something over something. Somebody give me one. Sine of angle A would equal H over B. You guys agree with that? Using this left-right triangle here. Okay, so let's write that one down. The sine of angle A would equal H over B. All right. Let's use the right triangle then, or the one on the right. Okay, and let's make another sine ratio. Derek.
Sine of B equals H over A.
Okay, so the sine of angle B would equal H over A. Okay. Yep.
Could the cosine of B would be C divided by 2 over A?
We don't know if it's C divided by 2. We don't know for sure it was split in half.
Yeah.
I mean, I drew a big enough triangle that it almost makes it maybe looks like it. But, you know, if I would have done more of dropping this third side, if I would have dropped it more down like that, then you definitely would have been able to tell that it's not exactly half.
Yeah.
Okay, so I just drew it big enough so we can do a little bit of work. All right, so these are our two sine ratios that we could write. I kind of want to get this H out of there because in the beginning there was not really an H to begin with. Okay, so let's try and get that H out of there. How might we get one of these equations to not have an H in it?
Use Pythagoras theorem.
You essentially could.
Solve for H and then plug H into the next problem.
We get one of the H's by themselves and then use what H is equal to plug it into the other problem, then you only have A's and B's. Okay? And the problem with Pythagoreans is you don't know that bottom side of that triangle to begin with. You don't know if it's half C. Okay? But I like the idea otherwise. So, doesn't matter which one. Just because I got more room over there, I'm going to solve for this h right here. How am I going to get this h by itself? Multiply both sides by b. So that'll give me b times the sine of a equals h. And so then I can take b sine a and substitute it right over there. Because that's what h is equal to. If h is equal to something, I can take that something and substitute it in for the h. So that'll give me the sine of angle B equals B sine A over A. And then, being that I know what the law of sines is, you guys do not yet, but I'm showing you how we're getting there, okay? I'm going to get all my b's onto one side of the equal sign, both the angles and the sides. So what would I have to do to get this b to not be on this right side? Multiply. Okay, I want to do it in less steps than that. I know where you're going with it. Okay, I want to do it just in one step right now. What could I multiply both sides by? And that b would be gone.
1 over b.
1 over b. Yep. Multiply both sides by 1 over b. If you multiply this by 1 over b, what happens to the b's? They cancel out. Okay? Cancel, cancel. Now what you have is you have the sine of b over b equals the sine of a over a. Any questions on that step, algebraically? Okay. So what this is showing you is if you have any triangle, doesn't have to be a right triangle, it works for right triangles, okay, but I don't know why you would use this for right triangles. You would just use SOHCAHTOA if you had a right triangle. But for any triangle that you had, okay, the ratio of the sine of angle B over its corresponding side, so the sine of angle B over side B, is going to equal the same ratio as the sine of angle A over side A. Those ratios will always be equal to one another, and you can use this proportion to help you find missing parts of a triangle. All right?
Same with the other way, so it'd be sine of a over a equals sine of b over b.
Other way around would work. Also, I'm not going to go through the proof of it, and neither will you, but these two things, so we said the sine of A over A equals the sine of B over B. That's what we had right here, just had it flipped around, right? And I could do a proof another way, so I could kind of take this triangle, turn it, and then cut angle A in half using its altitude, and I could do it again, and I would eventually also get the same thing, sine of C over C. Okay, I do the proof the exact same way. You're not going to have to do the proof the exact same way. Okay, you just need to get to right here as far as the deriving goes. All right, you're not going to have to do it for all three sets of sides. If you wanted to do it for all three sets of sides, you certainly could. But as far as your test is concerned, when I ask you to derive the law of sines, okay, first of all, this is the law of sines right here. Okay, your book has it flipped around. Okay, it's fine. You can memorize it flipped around if you would like, okay? But this is the easiest way to derive it, so this is kind of the way that I'll always write it, okay? If I do write it another way, it's just because I know I can do it that way. It really doesn't matter. If I flip them, all of them upside down, that's fine, okay? But as far as your deriving, I'm just gonna ask you to get to this point, because really, once you've gotten to that point, you've got a good chunk of your law of sines derived. Okay? Questions, Derek?
If we wanted to derive the angle C, don't we just set up the same ratio except put C in and then?
Yeah, you'd have to draw or look at the triangle differently here, and drop make a right triangle differently. And then you'd go, yeah, the sine of C equals H over B. The sine of B equals H over C, and then you do it exactly the same way to get C's involved in your. What you'd get in that case is you would get sine B over B equals sine C over C. You'd get another pair basically.
And then you could just put sine A over A equals sine B over B.
Well, yeah, and since this equals this, and this also equals 1 with the C's, well then they all equal each other by substitution, or maybe even the transitive property if you really go back to geometry, I suppose. Okay. So, this is your law of sines. These ratios will all be equal to each other, alright? I will give you this picture and ask you algebraically to get to this right here. That is on your quiz. Okay? You'll write two sine ratios, you'll solve for H, plug it in the other one, do a little bit of algebra, and get to that point. Okay? Questions on deriving? Okay? So, example. Let's say we got angle A is 62 degrees, angle B is 59 degrees, and let's say that side A is 8 units long, 8 centimeters. And I'm just going to we're going to solve the whole triangle. Solve triangle, we'll call it triangle ABC. So we're going to find all the missing parts of that triangle.
Well, if we know two angles, we can find the other one.
Yep. The first thing though you guys will want to do, draw a triangle. I mean, let's just use a picture here, alright? You do your best. Obviously, if one of the angles is larger than 90 degrees, draw that to scale. Okay, if one of the angles is larger than 90 degrees, try and draw it to scale. But here, actually, if you look at it, all the sides or all the angles are going to be pretty close, actually, aren't they? Real close. Okay. But I'm not going to get too picky on the drawing here. If I call this angle A, I know that's 62 degrees. Doesn't really matter if I call this angle B right here, that's 59 degrees. Again, your drawing would not have to be exact by any means. Side A is always across from angle A, so that is 8 centimeters long right here. Here's side B, here's side C. So I draw a picture to go with my information that was given to me. Okay? That was my information that was given. I draw a picture. Now I just got to find the missing parts. Derek said, well, if you got two angles, you can figure out the third one. Yep, because all three angles got to add up to 90. So you know that angle C is how much? Is it also 59?
What's 69? Right.
So angle C is 59, right? Now what actually then is true about this triangle? Isosceles, so B and C would be the same. Okay? That won't always happen, believe me. But, can you use SOHCAHTOA here?
No.
With how it's drawn right now, can you use SOHCAHTOA? No. And if you want to create a height and do that and use SOHCAHTOA, you certainly can, but what I want to get you in the habit of doing is using the law of sines. Okay? You can't use SOHCAHTOA the way we have it drawn now because we don't have a what? We don't have a right triangle. Okay? So, go to have a little work here, alright? We know that using law of sines, I know angle A and I know side A, right? I know those two amounts, so that's going to be the start. How big was angle A again? 62? Okay, so the sine of 62 over 8 has to equal, let's just solve for B, the sine of 59 over B. You see how I'm just using the law of sines there, plugging in the values that I know? And I just have one variable in that proportion, okay? I just have one variable in that proportion, so you should be able to solve for that variable, okay? How do you solve proportions? Cross multiply. So B times the sine of 62 degrees equals 8 times the sine of 59 degrees.
Then would you divide by sine 62?
You divide both sides by the sine of 62 and you will have your B value. Divide by the sine of 62, divide by the sine of 62, they cancel out, and B is approximately, that'll help from people with calculators, make sure you're in degree mode. Make sure you close off your parentheses.
7.766. So
7.77. Okay. Could we also have solved for side C as well?
Yes.
We just would have used sine of C happens to be 59 as well right here. Okay, we just could have used that other one if we wanted to solve for sine C or for side C.
Well, we have to do that on a test.
Okay. What's that?
Solve for sine C.
Well, actually, on this problem, we're finding the whole thing.
Oh, we are.
Yeah, yeah. But because this is isosceles, what's C going to also be? C is going to be the same thing, so it wasn't a great example in that sense. Okay. But had I wanted to find C, I would have ignored this one and set up this equation. The sine of 62 over 8 equals the sine of 59 over C, and do the same thing over again. Okay? So we got B, we got C, and we got angle C right there. So we found the other three missing parts. Okay, we were given angle, angle, side. All right, we were given angle, angle, side. We found the other three missing parts to solve that.
So if we
That's
took
right.
sine 59 over B and like did the ratio and it equals sine 59 over C, we'd get the same thing.
If you do that, make sure you don't use the rounded answer of B. Use the whole thing.
Okay.
Yep. So that's why I'd probably just go back and use this one. I'd say this equals this. That way you don't have to use that long decimal in the previous answer button.
Yeah.
Okay? Once I found one of the other sides, I'm just pointing out common mistakes here. Sometimes people do this. They find one of the sides, and then they use Pythagorean's theorem to try and find the third side. Why does that not work?
It's not right triangle.
It's not a right triangle. Okay? And you may laugh at that, but that happens. Okay? People are in a habit of using Pythagorean's theorem to find missing sides. Remember, Pythagorean's theorem, SOHCAHTOA, those ratios only work for right triangles. Okay? All right. Some practice. Page 316, 11 through 16, 32 and 33. Page 316, 11 through 16, 32 and 33,